Today, we're diving into a potential solution for a problem that stumped the greatest minds in science for, over 300 years. It's a puzzle so famously tough, it's pretty much become the definition of chaos itself.
And this question gets right to the heart of it. We can map out the cosmic dance of two bodies, like the Earth and the Moon, with incredible precision. But the moment you add a third body to the mix, everything it breaks down. It becomes completely unpredictable. That, right there, is the legendary three-body problem.
So here's our game plan. First, we're going to really understand the problem itself, what we're up against. Then we'll introduce a pretty radical new way of looking at it. We'll explore how this new idea claims to solve the whole thing, lay out exactly how it can be tested, and finally, we'll touch on the absolutely staggering implications if it's right.
For generations, really, the three-body problem has been this kind of mathematical wall. It's the point where our ability to predict the future just stops, and chaos takes over.
Okay, imagine you're trying to predict the path of a single pinball. Now, what if that pinball was also a magnet, and so were all the bumpers it's bouncing off of? Every object is constantly pulling and pushing on every other object. It creates this web of forces so tangled up that the tiniest change at the start sends them all on wildly different, unpredictable paths. And that, in a nutshell, is the three-body problem. It's the textbook definition of chaos.
But what if chaos isn't some fundamental law of the universe? This is where this whole idea gets really interesting. It suggests that chaos is just a symptom of something else, something called phase drift. Think of it like this. You've got three amazing musicians all trying to play the same beautiful song, but they've all fallen out of rhythm with each other. The result isn't music, it's just noise, right? It's chaos. But if you can get them all back in sync, the harmony returns. And that idea brings us to a completely new paradigm, one that suggests the universe actually operates on a kind of hidden rhythm.
At the very heart of this new approach is one single equation. It's the formula for something called Triune Harmonic Dynamics, or THD for short. And it makes a really bold claim that all transformation in the universe, everything from the quantum level all the way up to the cosmic scale, follows one single, predictable, repeating pattern. And that pattern is basically a three-step dance. First, you have emergence, the birth of something new. Then comes contrast, a period of tension, of conflict. And finally, you get integration, where that conflict resolves into a brand new, more stable state. And this cycle, it's said to repeat over and over and over again at every single scale of reality.
Okay, so how does this universal rhythm actually solve the problem of three bodies flying through space? Well, this is where we get to see the theory in action, and it reveals this hidden mechanism that supposedly turns all that chaos back into order.
The theory introduces a new concept called orbital pressure. And the best way to think about it is like mathematical friction. It's the tension that gets created when three objects are all pulling on each other, but they're not in sync, they're out of phase. This pressure is what generates all the heat and noise that we call chaos.
And here's where we see that 3-6-9 pattern applied directly to the problem. The system starts at a state of 3. That represents the three bodies, each with their own independent potential. Then it moves to 6, which is a state of conflict, where gravity is creating that orbital pressure we just talked about. But it doesn't stay there. The theory says the system naturally wants to find 9, a resolution, where the bodies snap into a perfect harmonic lock.
And this right here, this is the big aha moment of the whole theory. Stability is an informational lock. Imagine three spinning gears that aren't quite meshed together. They're just going to grind against each other, creating heat, noise, chaos. But when they finally click into place at just the right speed, they lock together and become a single, smooth-running machine. Well, according to this theory, that's exactly what happens with the three bodies. Once they sync up their frequencies, that friction of chaos just vanishes, and they start behaving as one predictable system.
Now look, a big idea like this is just a cool story if you can't prove it. And that's why this theory comes with 3 very specific, very testable predictions. This is what good science is all about. If these predictions turn out to be wrong, then the theory is wrong. Simple as that.
So, the first testable prediction asks us to look up at the stars themselves. It suggests that we've been missing a fundamental pattern in how solar systems are actually put together.
This theory predicts that if we go out and survey stable three-body systems all across the galaxy, their orbits won't be random at all. Instead, we should find them clustered at very specific mathematically harmonious distances from each other, kind of like musical notes that form a perfect chord.
And in between these stable spots, these nodes, there should be these empty gaps where systems like that just can't exist. If that's true, it would mean nature itself has a clear, undeniable preference for harmony.
All right, the second prediction. This one moves from looking out at space to what we can measure right here in the lab. It proposes that we should be able to detect a very specific signal, a kind of birth cry of order, at the exact moment a chaotic system snaps into stability. So the idea is, as a system gets closer and closer to this informational lock, that orbital pressure we talked about builds up to a peak right before it's suddenly released. And that release of pressure should be detectable as a measurable high-frequency chirp. Finding that signal would be like hearing the final, fleeting gasp of chaos right before it gives way to the calm of perfect order.
And that brings us to the third and final prediction. And honestly, this one might be the most ambitious of them all. It moves us from just watching what happens to actively getting involved. It suggests we don't have to wait for harmony to show up, we can create it.
It proposes that we could take a chaotic three-body system, whether it's in a computer simulation or a real lab experiment, and we could actively force it into a stable lock. And how would we do that? By injecting a very specific harmonic frequency from the outside. Think of it like playing exactly the right musical note to calm a violently vibrating string. I mean, if chaos can be tamed on command, that changes everything. So, let's just imagine for a second that these predictions hold up. If they do, then solving the three-body problem is really just the beginning. The implications of this framework would stretch far, far beyond the stars. Think about it. If this 3-6-9 pattern of emergence, conflict, and resolution is truly a universal principle, then it doesn't just apply to gravity. The same logic could become an incredibly powerful tool for understanding any complex system. We're talking new insights in physics, maybe even biology. It could even give us a new way to manage chaotic human systems, from how we train AI to how we stabilize financial markets or global supply chains.
The ultimate vision here is, well, it's profound. It's suggesting that THD isn't just a formula, but it's a kind of universal grammar for reality itself. A single repeating pattern that connects the smallest atoms to the biggest galaxies, and maybe, just maybe, even to the way we think.
And that really reframes how we look at the cosmos, doesn't it? It's not a picture of a universe that's just falling apart into random chaos. It's a picture of a universe filled with potential for order, just waiting for the right harmonic key to be turned in the lock.
So this entire groundbreaking framework, from its core mathematics all the way to its testable predictions, was proposed by researcher, inventor, and author Kevin L. Brown. It presents a real scientific challenge to the old idea of chaos, suggesting instead that a deep, harmonic order is out there, just waiting for us to find it.